Good day everyone. I am Roy Fernandez.
And I am Gana. Today, we will be presenting number 1.56 for our CHE 131. And the problem goes like this.
In the thermal processing of semiconductor materials, annealing is accomplished by heating a silicon wafer according to a temperature-time recipe and then maintaining a fixed elevated temperature for a prescribed period of time.
For the process tool arrangement shown as follows, the wafer is in an evacuated chamber whose walls are maintained at 27 degrees Celsius and within which heating lamps maintain a radiant flux at its upper surface. The wafer is 0.78 mm thick, has a thermal conductivity of 30 watt per meter Kelvin and an emissivity that equals its absorptivity to the radiant flux, which is 0.65. For the heat flux of 3 times 10 to the power of 5 watts per meter squared. The temperature on its lower surface is measured by a radiation thermometer and found to have a value of 997 degrees Celsius.
To avoid warping the wafer and inducing slip planes in the crystal structure, the temperature difference across the thickness of the wafer must be less than 2 degrees Celsius. Is this condition being met?
Given the figure in the problem, we can picture out the process and identify the known values. This is the silicon wafer in an evacuated chamber whose walls maintained at 27 degrees Celsius. It has a thickness of 0.78 mm, a thermal conductivity of 30 watts per meter Kelvin, emissivity that equals its absorptivity, which is 0.65. This silicon wafer is radiantly heated by lamps with a heat flux of 3 times 10 to the power of 5 watts per meter squared, experiencing an annealing process with known backside temperature of 997 degrees Celsius.
In the said problem, what we need to find out is whether the temperature difference across the thickness of the wafer is less than 2 degrees Celsius for it to avoid damages.
This will be the schematic representation for the given problem.
Before we start our calculation, we'll have some assumptions. First, it is in steady-state conditions.
Second, one-dimensional conduction in wafer.
Third, there is a radiation exchange between upper surface of wafer and surroundings as between a small object and a large enclosure.
Fourth, vacuum condition in chamber, no convection.
Now we'll proceed to our calculations. First, we will have a surface energy balance so we can determine the temperature. The process include the absorbed radiant flux from the lamps, radiation exchange with the chamber walls, and conduction through the wafer.
After rearranging and substituting the values from different equations, we get 1000 degrees Celsius.
Since the temperature difference is more than 2 degrees Celsius, and has a 3 degrees Celsius difference to be exact, then the warping of the wafer and inducing slip planes in the crystal structure could occur within the process.
That's all. Thank you for listening. I am Gana.
And I am Roy. Have a nice day.